Okay, I'd like to talk about half-life, which is related to nuclear decay, of course. And basically, half-life is it's the time it takes for half of a sample, half of the atoms in a sample to decay. As nuclear things go along, we have kind of a probability of time in which it takes half of a sample to break down, for those particles to go through nuclear decay, alpha, beta, or whatever, emit their particles, and then, you know, turn into whatever the next thing is they're decaying into. So what ends up happening is you have this process. You know that the half-life, which can vary from millions of a second up to, billions of years, is the time it's going to take for half of a sample to break down. So I want to just show you a couple of problems how you would work through these things, which I think is very illustrative of how the whole process would come about. So as I look at this one, and let me make that a little bit bigger so I can write in here more comfortably. At time 0, they're telling me I'm starting with 128 grams. They tell me the half-life is 5,730 years. So what that means is if I go 5,730 years, half of this original 128 grams would have broken down. And so what I will have then is 64 grams remaining at that time. Now, after another 5,730 years, so now my total time would be 11,460. What's going on is it's not that the other 64 grams breaks down. What it is half of the remaining breaks down. So this 64 of that, I'm now going to be down to 32 grams, because 32 grams 64 grams would have, I would have started with that, 32 grams would have decayed, and I'm now left with 32 grams. Now, after another 5,730 years, which takes me to a total time of 17,190 years, this 32 grams would have decayed to 16 grams. And so you see what's happening. Every 5,730 years, half of my original amount decays. I started at time 0 with my original amount, and I just keep adding the half-life in this column, and I keep cutting the amount in half as I work down this column. Now, in another 5,730 years, which I believe takes me to a total of 22,920 years, this would now be 8 grams. And so you kind of see how that process worked. How long? The question says, how long would it take until 8 grams remains? It would be 22,920 years. So that is one way we could ask a question. We could say to you, here's the half-life, here's the starting amount. How long until a certain amount remains? Another type of question we could do would be something like this one. How much will remain after a certain number of hours? So up here we were saying, how long will it take to break down? Here we're saying, well, here's a certain amount of time. How much will remain after that amount of time? So again, we're starting at time 0, and they're telling me I am starting with 20 grams. My half-life is 200 hours, so after 200 hours, I will be down to 10 grams. After 400 hours, I would be down to 5 grams. And after 600 hours, which is what they're asking about, 600, I'd be down to 2.5 grams. And so that's your ultimate answer, because what they're saying is how much will remain after 600 hours. So here we are at 600. So we've gone through 1, 2, 3 half-lives, and we cut this amount in half 3 times. And so we end up with 2.5 grams. Okay, and then there's one other style of problem I would like to show you. And this is where I give you the amount at the end. 86 is a good example of this. And this is the sort of thing that might happen. Sample of air from a basement is collected to test for the presence of radon, which has a half-life of 3.8 days. However, delays prevent the sample from being tested until 7.6 days have passed. Measurements indicate the presence of 6.5 grams of radon-222. How much was there initially? So here's what's going on, and in this case you have to write everything yourself. You need your amount. I'm going to abbreviate that as N, and we're going to do time over here. And what's happening is at time 0, I would have had a certain amount of stuff, and I'll show you what I mean here in a second. After 3.8 days, that's 1 half-life, I would have had half that of stuff, and after 7.6 days, I'd have had half that amount. So what this is telling me is I've gone through 2 half-lives to get to 7.6 days. And what's happening is rather than giving me the original amount and I cut it in half, they're telling me at 7.6 days, I have 6.5 micrograms. So if we're going to come down and cut it in half as we go down, to say how much did we have originally, we have to double to go back up. So 6.5 times 2 would be 13. Doubling that would be 26. So what this means then is at time 0, I would have had 26 grams. After 3.8 days, I would have been down to 13 micrograms, and after 7.6 days, which is the time they give me in the problem, I would be down to 6.5. So they're giving me the amount at the end and asking for the original amount. So what I do is I just start at the end and I work my way back up to the top. So those are just generally the sorts of kind of typical, fairly straightforward, simple half-life problems you do. You can get more complicated with this. You can use natural logs and go, a half-life or 4.2 half-lives, and there's some mathematics there. But generally, I'm just going to give you straightforward things that, your numbers and times are always right on a half-life. Okay, thank you very much.